Hello everyone, this is Shraddha Bhurre from IAPS DAV Indore, and I am going to explain algorithm for solving a differential equation. Predictor corrector method. What is this method? This method is used for calculating the numerical solution of differential equation. What we meant by the solution of differential equation? So this solution is curve that is g of x comma y in some plane x comma y whose slope at every point is given by dx dy by dx equals to f of x comma y. The initial point and the slope are given, and we are asked to extrapolate the value of y for the set of value of x in the range x1 up to xf. Euler's formula for solution of differential equation. By this we extrapolate the value of y. So this is the formula of for solution of differential equation, and this is Heun's formula for solution of differential equation, which we will going to use in our algorithm of predictor corrector method. So in this Heun's formula, SI is slope of straight line at the initial point, and SI plus 1 is the slope of straight line at the next point. So slope of straight line is given by f of xi comma yi and f of xi plus 1 comma yi plus 1. This is equals to yi plus 1, and this is obtained from our Euler's formula, that is by this. In above method, yi plus 1 in solution is evaluating using only point yi. We can see that we don't include our previous point. So for use of previous point in involving a solution, predictor corrector method is used. So solution at xi plus 1 are found to be yi and yi plus 1. So solution at xi plus 2, that is at next point, may be extrapolate from yi and yi plus 1 by fitting a quadratic. So here we assume that our y of x is a quadratic and dy by dx is linear. So the coefficient a, b, c may be obtained by the following equation. We substituting this equation in our quadratic equation, we will have the value of a, b and c, and our value of a, b and c are first of all, when we substitute y equals to y1 and x equals to x1 in this equation, so we'll have a equals to yi, because this figure is going to be 0 and this also will going to be 0. So our value of a is yi. We'll same do for the value of b and c, and we will have the value of b is this and value of c is this. Using this value of a, b, c, y at xi plus 2 may be obtained from the quadratic equation. This is our predicted value. The subscript p indicates that this is an extrapolate or predicted value. We also can assume dy by dx as a linear, and the area under curve can be found from the xi plus 1 and xi plus 2. So this area b can be found out by the trapezoidal rule, and this area will going to be this h by 2 f of xi plus 1 and yi plus 1 plus f of xi plus 2 comma yi plus 2 predicted. We'll use the predicted value of yi plus 2. Another estimate of yi plus 2 may be obtained by adding this area to yi plus 2. So we'll have our corrected value of yi plus 1. So the equation, this predicted equation and this corrected, constitute a predicted corrected method to developing the solution of differential equation from xi comma yi, xi plus 1 comma yi plus 1 to xi plus 2 comma yi plus 2. Our first step of our predicted corrected method is we have the value of x1, y1, h is the difference between the two successive values for x, and xf is the final value, or we can say the last value of x. So by x1 and y1 we can find out the slope for the initial point, that is s1, that is f of x1 comma y1. So by this we can find our s1, and for s2 we need two things, x2 and y2. So our x2, that is next point, is x1 plus h, and our y2 can be evaluated from our Euler's formula, that is yi plus 1, that is here I is 0, so yi plus 1 is y1, and h into f of xi comma yi, so here f of xi comma yi is si, so here s1, s2, then we'll calculate by the f of x2 comma y2, and finally the predicted the extrapolated value of y2 will obtain by this formula. Heun's formula for solution for differential equation. Now our loop start from x2 and will continue till x2 value of x2 is less than or equal to xf, that is final value. So first of all, we calculate the value of s2, that is f of x2 comma y2 with the new value of x2 comma y2, and by the predicted corrected formula we have to find the value of x3. Now in x3 we are going to put the value of y3, predicted value of y3 by this formula. This is predicted value formula, and at the next step we will find the corrected value of the differential equation, and the next step value of y2 will going to be y1, and value for corrected is on y2, and x3 at x2. So for the next step, that is when our loop continue to the last value, our values for y1, y2, x2 will change. So now we can check our algorithm for with an example. So here is our equation, dy by dx equals to minus x comma y, xy, and y of 0 equals to 1. We have our second equation, y of x1 equals to y1. By this we can see that x1 is 0 and y1 is 1, and our formula of extrapolating y3 predicted and corrected is this. Solution started from Heun's method by our algorithm. So value of x1, y1, xf which is given 0.25 and h is 0.05. By this we can find the value of s1, that is the slope at initial point minus x comma y, that is x1 is 0 and y1 is 1, so our value of s1 is 0, and the value of x2, that is x1 plus h, is 0 plus 0.05 equals to 0.05. Similarly for y2, so by this we can find the value of s2, that is slope at the next point, f of x2 comma y2, by this. So at last we have our extrapolated value of y by our Heun's formula. Now next, by predicted corrected formula, our x1 is 0, y1 is 1, and our x2, that is we have calculated the value of x2, that is 0.5, and y2 is 0.99999. Step 10 from the algorithm, that is the step f of x2 comma y2, slope of the next slope of the straight line at next point. This s2 equals to minus x comma y, so value of x is 0.05 and y is 0.999. So our S2 will be calculated as this, and after this we have to calculate the predicted value of y3 and corrected value of y3, and this loop will continue till x2 less than equals to xf, this, and that is up to 0.2 less than equal to 0.25.